Imagine it's like 5 o'clock in the evening.
The absolute worst time to be downtown.
Right, exactly. Rush hour is peaking. You're just wrapping up work, you pull out your phone and you tap a button, and then within maybe 40 seconds, this sleek little two-seater vehicle just glides right up to the curb.
No driver.
No driver. I mean, there isn't even a steering wheel in the front seat.
Yeah, completely empty.
So you get in, and it just smoothly navigates through all that gridlock, drops you right at your front door, and then your phone pings with the receipt. 85 cents.
Wow. Yeah, that's the kicker right there.
It's literally cheaper than the calories of food you would have burned if you just walked the exact same distance.
It's wild. I mean, it completely breaks our mental model of what transportation is actually supposed to cost, you know? When the sheer physical movement of a human body gets that cheap, it really stops being a consumer product.
Right. Becomes something else entirely.
Yeah. It starts becoming a utility, like turning on a tap and getting water.
And that is exactly what we are dissecting today. So for everyone joining us, it is April 6, 2026, and we are looking at how a very specific conversation that's happening online right now is basically exposing the end of the public bus as we know it.
Which is a huge claim to make.
It is. But as someone who, wants to stay ahead of the curve without having to read hundreds of pages of technical AI manuals, this deep dive is built specifically for you. We have this fascinating thesis that was just published this morning by entrepreneur and activist Paramendra Kumar Phagat on his blog, Netizen.
Yeah, and it's a brilliant piece of synthesis. He's looking at these real-time statements from Elon Musk and various AI researchers.
Right.
And he's combining all of that with actual operational data from the streets of Austin, Texas today.
Mm-hmm.
And he formulates this incredibly radical conclusion.
Because we're not just looking at, another shiny tech update about self-driving software. That's not the mission today.
No, not at all. We are investigating a fundamental tear in the fabric of civic infrastructure.
Yeah, the premise Phagat puts forward really forces us to look past the hardware. I mean, we get so distracted by, the cameras, the neural nets, the whole look ma, no hands thing.
Oh, absolutely. The novelty of a missing steering wheel takes up all the oxygen in the room.
Right. But the true innovation arriving this year isn't really the autonomous car itself. It is the cost structure. It's the underlying unit economics of the whole system.
Exactly. Phagat's thesis basically argues that a point-to-point robotaxi network is uniquely positioned to just entirely replace municipal bus systems.
Because it attacks the single biggest vulnerability of traditional transit, which is those massive, completely inflexible operating costs.
Yeah, we hear tech companies promises a revolution, like every other Tuesday.
Oh, constantly.
But they rarely deliver actual cost breakthroughs that impact, your daily commute. But what happens when point-to-point transportation becomes cheaper than a municipal bus pass?
It's not just about cool cars anymore. It's about unlocking what the sources call latent mobility for everyone, everywhere.
Right. So let's trace this back to the actual spark, because this massive thesis was actually triggered by a surprisingly brief exchange on X just hours ago.
Yeah, let's break that down. Because it started with a tech analyst named Adam Lois, right?
Right.
He posted this thread analyzing Tesla's full self-driving software.
Yes. And what's interesting is he wasn't talking about economics at all. He was purely focused on public health.
Right, the safety aspect.
Exactly. Losis stated that the software is approaching this threshold where it will eventually save like 99% of the lives currently lost in traffic accidents.
Which is a crazy number to throw out there.
It is. And then Elon Musk replied to that specific claim with just a single word. He just said, yes.
Yes, yes.
Yeah, which is a staggering baseline to start from. I mean, to put that 99% number into context for you, human drivers globally cause roughly 1.19 million fatalities every single year.
Wow, over 1 million.
Yeah, so shaving 99% off that figure, it fundamentally alters the actuarial tables of human existence.
But wait, let me stop you right there, though, because I see that 99% stat thrown around in press releases constantly, right? And it always sounds like marketing math to me.
Sure, it sounds inflated.
Yeah, how does a piece of software actually achieve a 99% reduction in fatalities compared to a human being? I mean, I have a vested biological interest in staying alive beyond feel. A computer doesn't care.
Right, but it comes down to processing bandwidth and hardware continuity.
Yeah.
So think about your own biology for a second. The human eye operates using these things called saccades.
Saccades.
Yeah, they're these rapid, jerky movements your eyes make. We actually only process high-resolution visual data in this tiny little circle right at the center of our vision. It's called the fovea.
Okay.
Your brain literally hallucinates the rest of your peripheral vision based on context. It's just guessing what's there. And crucially, you can only look in one direction at a time.
So if I'm checking my blind spot over my left shoulder.
You are completely 100% blind to the car braking right in front of you.
Right. Not to mention, I might be tired or I might be sneezing or just thinking about what I'm going to have for dinner.
Exactly. Human attention is basically a degraded, single-threaded processor.
That's a great way to put it.
Now, compare that to the hardware suite on a 2026 Tesla. You've got 8 high-resolution cameras processing 360 degrees of the environment simultaneously.
Wow.
And they're operating at 36 frames per second. The vehicle never blinks. It never gets distracted. It literally doesn't have a blind spot. And its reaction time from the exact moment a photon hits the lens to the moment torque is applied to the braking caliper, it's measured in milliseconds.
So it's not just that it's like, quote unquote, smarter than a human driver. It's that it has this completely unfair sensory advantage. It is biologically impossible for a human to process that much spatial data that quickly.
Precisely. And this is exactly where Paramendra Bhagat chimes into this thread on X. Because Lois and Musk are talking about saving lives, right?
Yeah.
But Bhagat drops the real crux of today's deep dive. He points out that while safety is obviously this necessary foundation, safety alone doesn't actually change society.
Right.
He writes, and I'm quoting here, "What is missing is the business model that takes it to everyone. Solution. Turn the robotaxi into the public bus. You ride for a few bucks."
That distinction is everything, really. I mean, if someone engineers an uncrashable car, but it costs, $150,000, it's just a luxury good.
Right. It just saves the lives of affluent people.
Exactly. It doesn't move the needle at all for, say, a single mother taking a 2-hour bus commute across the city. It reminds me a lot of early internet speeds.
Oh, so.
Well, getting a faster internet connection back in the day was great. That's kind of like the safety aspect here. But the real revolution, the thing that changed the world, was when the data became cheap enough that anyone could stream video. That's the business model aspect.
That's a really sharp analogy. Technology without an accessible business model just remains a luxury good. But for God's insight here, it shifts the paradigm from, oh, this is a cool car replacement for the middle class to, no, this is universal public infrastructure.
And that business model is intrinsically tied back to the safety metric, isn't it?
Completely. When a fleet achieves a 99% reduction in collision rates, the immediate downstream effect is this massive collapse in insurance premiums.
Oh, because they just aren't crashing.
Right. Insurance is one of the largest fixed costs of operating any commercial fleet. Whether you're a taxi company, an Uber driver, or a municipal bus authority, insurance is a huge line item. If your fleet functionally stops crashing, your actuarial risk just approaches zero.
So your overhead drops massively.
Exactly. Gott realizes that this safety milestone they're hitting is actually an economic lever.
Okay, but this isn't just theory anymore. We can't just analyze tweets and blog posts all day. We have to look at the pavement.
Let's do it.
Because right now, today, in Austin, Texas, Tesla is actually operating a live commercial robotaxi network. They are using what they call unsupervised Model Y vehicles.
Right.
But before we look at the actual numbers, we need to define that term for the listener. What does unsupervised actually mean in the whole hierarchy of autonomous engineering? Because, for the last decade, we've had people sitting in the driver's seat with their hands just awkwardly hovering over the wheel.
Right. The hovering stage. So that hovering stage is what the industry generally calls level 2 or level 3 autonomy. The car is technically doing the physical driving, but the human is the legal and the practical supervisor. You have to be ready to intervene at any second.
Right.
But unsupervised, which operates in the level 4 or level 5 domain, means the human is entirely removed from the liability loop. In Austin right now, passengers are getting into vehicles where there's literally no employee in the front seat.
That still blows my mind a little bit.
It's wild. The software is making all of the localized tactical decisions.
So what's driving this software leap? Because, just a few years ago, autonomous vehicles were totally struggling with, basic construction zones or erratic pedestrians crossing the street. The sources keep mentioning these FSD V14 plus neural nets.
Yeah.
Unpack that for us. What changed between the old software that struggled so much and this V14 system that's legally allowed to drive completely empty?
It really comes down to a fundamental architectural shift. They move from heuristics to end-to-end neural networks.
Okay, what are heuristics exactly?
So historically, self-driving code was written by human engineers using heuristics, which is basically just millions of lines of if-then statements.
Oh, like if this happens, do that.
Exactly. Like,
Yeah.
if the camera sees a red octagon, then apply the brakes at this specific rate of deceleration.
Which honestly sounds super logical until you encounter, a guy in a chicken suit holding a stop sign upside down while riding a unicycle.
Exactly.
Hmm.
The human engineer didn't write an if-then statement for the unicycle chicken, so the car just freezes. It doesn't know what to do.
Because the real world just has infinite edge cases.
You cannot hard-code reality. It's impossible.
Mm-hmm.
So what Tesla did, starting with FSD V12, and now scaling massively into the V14 Plus architecture we see in 2026, is they basically scrapped the human-written code entirely.
Wow, really? Just threw it out.
Pretty much. Instead, they fed millions of hours of high-quality video data from actual human drivers into a massive AI neural network. The AI essentially watched billions of frames of humans successfully navigating really complex environments, and it learned to directly translate visual input into steering and acceleration output.
So photons go into the camera and steering torque comes out the other end.
Exactly. The network figured out the complex, unwritten rules of driving all on its own. It's basically intuition, but synthesized in silicon.
Okay, so the brain is fully operational, we get that. But let's look at the body now, because the Austin rollout right now is relying on these modified Model Ys.
Right, retrofitted cars.
Yeah, but this month, April 2026, marks the production kickoff of the actual purpose-built Cybercab at Giga, Texas. And the source data pegs the manufacturing cost of this new vehicle at roughly $30,000.
Which is incredibly low.
I really need to challenge this number, though. 30 grand for a cutting-edge autonomous vehicle. I mean, the average new car in the U.S. right now costs over $47,000, and that's just a regular gas car with human controls.
Right.
How are they building a futuristic robot for $30,000 without just taking a massive loss on every single unit?
Well, to understand that $30,000 price point, you really have to look at the manufacturing physics, specifically what they call the unboxed process and gigacasting.
Yeah, lay that out for us.
So traditional auto manufacturing is this very linear assembly line. You stamp out dozens of tiny little metal parts, you weld them all together into a frame, you paint it, and then you have factory workers trying to cram all the wiring and the seats through the doors.
Right. It's essentially Henry Ford's model, just, modernized with some robots.
Exactly. It's incredibly labor intensive. But the Cybercab uses gigacasting. They inject molten aluminum into these absolutely massive presses that cast the entire front and rear underbodies of the car as single solid pieces of metal.
Oh, wow. So you're just cutting out all those little pieces?
You eliminate hundreds of individual parts, hundreds of robots on the line, and massive amounts of factory floor space. And then you combine that with a structural battery pack.
What's a structural battery pack?
It's where the batteries aren't just dead weight for energy storage. They actually form the physical floor pan of the vehicle. They provide structural rigidity. So you strip out immense weight and cost right there.
And then you get to the interior, right? Because if there is no human driver, you don't need a steering column.
No steering wheel at all.
You don't need brake pedals, an accelerator, a rear view mirror, or any of those complex dashboard instruments that honestly just exist purely to feed information back to a human brain.
Exactly. When you remove the human control interface completely, the interior geometry simplifies dramatically. You aren't paying for the mechanical linkages. You aren't paying for the redundant safety systems for the steering column or the expensive display screens for the driver. You are just building this highly aerodynamic, ultra-efficient two-seat pod.
So that's how they get the capital cost down to 30 grand. That's the sticker price.
Right.
But let's look at the microeconomics of an actual ride, because this is where Bhagat's whole public bus thesis either lives or dies. Right now, in the Austin pilot, the pricing is a $3 base fare plus $1.40 per mile.
Which is current market rate, roughly.
Yeah, so if I take a 5-mile trip, I'm paying about $10. $10 is cheaper than an Uber, sure, but it is definitely not a $2.50 bus ticket. But the sources state Tesla's full-scale target is roughly 18 to 25 cents per mile.
Yes.
How on earth do we cross that chasm from $1.40 down to 20 cents? That seems like a massive jump.
We have to systematically deconstruct the operational cost drivers. If we build a P&L, a profit and loss statement for just a single mile driven, what actually goes into it? In a traditional Uber or a municipal bus, roughly 50 to 60% of the per mile cost is just human labor.
Oh, right. The driver's salary.
And the salary, Their healthcare benefits, their overtime, their downtime between rides when they're just sitting there, all of that is baked into your fare.
Okay, so the unsupervised level 4 software literally eliminates the driver. So we slice 60% off the top immediately. What's the next largest expense?
Fuel. Internal combustion engines are just thermally tragic, to be honest. They waste about 80% of the energy stored in a gallon of gasoline purely as heat and friction.
80%, that's
It's
terrible.
massively inefficient.
Whoa.
But an electric drivetrain is over 90% efficient at turning stored battery energy into forward motion. And furthermore, a centralized autonomous fleet doesn't charge at public fast chargers during peak afternoon hours when electricity is super expensive.
Oh, because they can coordinate.
Right. They route themselves to dedicated charging hubs at like 2 in the morning. They pull excess wind or solar off the grid at wholesale off-peak rates.
Yeah.
So your energy cost drops from perhaps 15 cents a mile for a gas car down to maybe 3 or 4 cents a mile for a hyper-efficient cybercab.
Okay, I follow the labor and the energy arguments, but I really have to push back on the hardware durability side of things.
Okay, let's hear it.
Because the entire economic model assumes these cars run 24/7 to amortize that $30,000 purchase price.
Right. High utilization.
But if a car is driving 20 hours a day and taking thousands of trips every single month, it is taking massive physical abuse. Tires wear out, the suspension degrades, someone spills coffee or, worse in the back seat at midnight.
Sure.
How does a 20-cent per mile fare absorb the cost of constantly replacing tires, cleaning the interior, and dealing with a vehicle that might just be driven into the ground in 2 years?
So that is the most common operational critique. And it's totally valid. The physical wear and tear is intense. But you're thinking about retail maintenance, not commercial fleet maintenance.
What's the difference?
Well, when a regular consumer buys tires, they pay a massive retail markup. When a fleet operator buys 2 million tires directly from the manufacturer, the unit cost plummets.
Okay, economies of scale.
Exactly. And more importantly, the vehicles use predictive AI maintenance. Because the car is literally just a rolling sensor suite, it knows exactly when a wheel bearing is exhibiting a microscopic vibration long before it actually fails.
Oh, wow.
Yeah, so it routes itself to a depot, a robotic gantry swaps the part in 10 minutes, and it's right back on the road.
What about the interior cleaning, though? People are messy.
Acoustic and visual sensors inside the cabin immediately detect anomalies. If a passenger spills something, the interior cameras flag it. The car automatically bills that specific user's account for the cleaning fee, takes itself out of the public queue, and routes to a depot where automated vacuums or specialized cleaning staff handle it immediately.
So it's not a disruption, it's just a process.
Exactly. It is a logistics flow, not a structural barrier. When you drive the car 150,000 miles a year, the $30,000 capital cost breaks down to just pennies per mile in depreciation.
So if we synthesize all of that, zero labor cost, wholesale electricity, commercial scale predictive maintenance, and massive asset utilization, that is how you hit 20 cents a mile.
You got it.
If I need to go 3 miles to the grocery store, the raw cost to operate that vehicle is only 60 cents. So even with a profit margin baked in, the consumer pays maybe $1 or $2. We have fundamentally undercut the municipal bus.
We absolutely have. But you just touched on the system-level paradox here.
What do you mean?
A single cheap car is a marvel of engineering. But a million cheap cars operating without coordination, that is a catastrophe.
Right. Because if a private ride costs $2, the behavior of the entire city changes overnight. At 5 in the evening, instead of 100 people cramming onto a single articulated city bus, all 100 of those people are going to summon their own individual 2-seater cybercab.
Naturally. It's cheap and comfortable.
Yeah, so you don't get a transit utopia. You just get the most technologically advanced traffic jam in human history. The physical geometry of city streets simply cannot accommodate that many individual metal boxes at rush hour, no matter how perfectly the AI drives them. So how does the system handle that kind of volume?
This is where Bhagat's essay shifts from the micro to the macro. He transitions into what is outlined as the hybrid master plan.
Okay, let's get into the master plan.
You cannot replace public infrastructure with a monoculture of 2-seater pods. A systemic network requires a 2-pronged approach, matching the vehicle form factor to the density of the demand.
Okay, lay out the first prong for us, because this involves a vehicle that isn't the Cybercab, right? The sources mention the Robovan, which was unveiled a couple of years ago, around 2024.
Right. The Robovan is the heavy lifter of the network. It is a fully autonomous, high-density vehicle capable of carrying 20 passengers at a time. Think of it as a driverless bus rapid transit, or BRT system.
Okay, for the listener who isn't an urban planner, how does a BRT work?
In urban planning, BRTs use dedicated lanes and really large vehicles to move massive amounts of people along high-density corridors. The Robovans serve this exact same function. They're deployed on the major arterial routes, so looping the downtown financial district, connecting major suburban transit centers, or running continuous routes straight to the airport.
So they act like the main arteries of a circulatory system, pumping massive volumes of human traffic rapidly across the city's core. And because there are no human drivers, you don't have schedule gaps when shifts change. You don't have a bus idling for 10 minutes at a station while the driver takes a break. They just flow continuously.
Precisely. They handle the bulk density. But traditional transit has always failed at the capillary level.
Which is the infamous last mile problem, right?
Yep. Exactly. A high-speed train or a BRT bus is highly efficient at moving you from one central hub to another central hub. But people don't actually live inside transit hubs. They live in residential neighborhoods,
Yeah.
usually a mile or two away from the main artery.
Right. And if that last mile is, a 25-minute walk in the freezing rain, or it involves crossing a dangerous 6-lane highway, the commuter will just say, forget it, and drive their personal gas car the entire way from their driveway all the way to the downtown parking garage.
Exactly. The macro system is only ever as viable as its weakest microlink. And this brings us to the second prong of the master plan, the last mile, on-demand service.
Which is where the smaller cars come in.
Right. This is where the Cybercabs and the modified Model Ys really excel. You ride the high-density Robovan along the main artery, you step off at a neighborhood hub, and your app has already summoned a Cybercab that is waiting there to take you the final nimble leg directly to your front porch.
The biological analogy just works perfectly here, like a computer network too, honestly.
Oh, how so?
It's like the Robovans are the massive fiber optic trunk lines carrying heady data traffic across the ocean, and the Cybercabs are the local Wi-Fi routing that data to your individual devices at home.
That's a perfect way to visualize it. And this hybrid approach also solves the off-peak crisis for municipal transit.
Oh, like late at night.
Yeah. Running a 40-foot diesel bus at 2 in the morning for 2 passengers is economically and environmentally ruinous. Most cities simply stop bus service late at night, which strands service workers and shifts demand to expensive Ubers. But in a hybrid AI network, the heavy Robovans park and charge during those low-demand hours, and the nimble, energy-efficient Cybercabs just seamlessly take over the entire network load.
And the sheer scale of this network expands drastically when we look at how Tesla actually sources these vehicles. Because it's not just vehicles manufactured and owned by Tesla, right? The sources explicitly note that starting in 2026, customer-owned vehicles are joining the fleet.
Yes, the platform opens up.
So if I own a fully capable autonomous Tesla, I can just tap a button on my phone and send my car off to work while I sleep.
Exactly. And this is a critical mechanism for load balancing. Transit demand is not flat. It has massive spikes during morning and evening commutes.
Right. Rush hour.
If a company had to manufacture and own enough vehicles to satisfy the absolute peak rush hour demand, they would be sitting on immense amounts of idle capital during the middle of the day. Those cars would just be parked.
Right.
But by allowing customer-owned vehicles to join the network just during peak hours, the system absorbs the demand spike without requiring Tesla to hold all those assets on their own balance sheet.
That's brilliant. The sources also mention that this allows for rapid geofenced expansion, targeting 70% of the U.S. population. Let's clarify that term, geofence, because honestly, it sounds like they are trapping the cars in some kind of invisible digital box.
Right, it sounds restrictive.
Yeah.
Yeah.
What does it actually mean for deployment?
So a geofence in autonomous terminology isn't necessarily a hard wall. It's more of a high-fidelity semantic boundary. An autonomous fleet relies on highly detailed, real-time mapping data, understanding exactly where the lanes are, how the intersections operate, where the speed limits change, all of that. A geofence rollout means the company has validated that their software has a statistically perfect confidence interval within a specific geographic area, say the city limits of Austin.
I see. So they know the roads perfectly there.
Right. And if the vehicle's mapping and sensory confidence drops below a critical threshold, perhaps on some unmapped dirt road deep in rural Texas, the geofence dictates that the commercial ride-hailing service just cannot route there. It's a safety parameter. But if the neural net trains on more edge cases, that geofence rapidly expands outward.
Okay, so we have the network architecture down, we have the capillary and artery system, and it's all bolstered by these customer-owned cars. But to truly grasp the economic shockwave this implies, we have to understand what happens when massive amounts of unused capacity are suddenly activated.
That's the really fun part.
It really is. Fagat's essay tries a very specific historical precedent to explain this, and honestly, reading it was an absolute light bulb moment for me. We have to talk about the Airbnb analogy.
It is the perfect framework for understanding what we call latent capacity. Fagat asks the reader to look at the hospitality industry prior to 2008.
Okay.
Before Airbnb existed, if you owned a home with a spare bedroom, or maybe a vacation cabin that you only used 3 weeks a year, that property was economically dormant. It was dead capital.
The physical space existed, the roof, the bed, the heating, it was all there. And somewhere in the world, a traveler existed who wanted to rent it. The supply and the demand were both there, but they were just invisible to each other.
Exactly. In economic terms, the transaction costs were simply too high. This relates to the Coase theorem, which is the idea that if transaction costs are too high, efficient market outcomes just cannot occur.
Right, because for an individual homeowner to market their single bedroom globally, process international credit cards securely, verify the identity and criminal background of a total stranger, and establish a mutual contract of trust. It was basically impossible. The friction was insurmountable.
So the asset just sat empty, doing nothing.
Yes.
Airbnb did not pour concrete. They didn't build millions of new hotel rooms. They built a trust layer. They built the digital infrastructure that lowered the transaction cost to zero.
They provided the identity verification, the payment escrow, the two-way rating system.
Exactly. By simply providing the software platform to connect existing latent supply with existing demand, they unlocked staggering economic value. I mean, they generated over $90 billion in U.S. economic activity in 2024 alone.
That's incredible. And if you think about your own driveway right now, or, just look out your window at the street, the average personal vehicle sits parked, turned off, depreciating in the sun for roughly 95% of its lifespan.
95%.
We have spent trillions of dollars mining lithium, stamping steel, and building these incredibly complex machines, only to leave them dormant for 22 hours a day. It is an astonishingly inefficient allocation of global capital.
And that is exactly Fagat's point. Tesla isn't just a car manufacturer building the next generation of the Model Y. They are building the trust layer and the software platform to activate the world's dormant automotive capital.
Just like Airbnb did for bedrooms.
Exactly. When a customer puts their car onto the network, the Tesla app handles the routing, the insurance liability, the payment processing, and the security monitoring. Just as Airbnb woke up dormant bedrooms, the Robotaxi network wakes up millions of dormant vehicles.
Because the roads are already built, the cars already exist. The human desire to move exists. Tesla is simply lowering the transaction friction to the point where the market clears.
You've got it.
It's like discovering an entirely new oil reserve, except the oil is just cars sitting in driveways. And when that supply floods the market, combined with the zero labor cost of the software, the marginal cost of a ride just crashes. It entirely democratizes access to point-to-point transit.
But, waking up the supply is only half of the equation.
Right.
You really have to look at how that cheap, ubiquitous supply fundamentally alters human behavior on the demand side. And this leads into the second major paradigm shift in Fagat's thesis. He moves from the Airbnb analogy over to the Google analogy.
This was the part of the essay that really shifted my perspective, because Fagat looks at human history and notes that for centuries, people basically walked around with trapped, unanswerable questions.
Like what?
Oh, like what is the specific half-life of carbon-14? Or who was the assistant director of that obscure 1980s movie? Before search engines, answering those minor questions required immense friction. You had to drive to a library, hope the encyclopedia was updated, or find a literal expert. Most of the time, the friction was just higher than the value of the answer, so you just abandoned the curiosity. It was latent.
And Google didn't invent the answers. They didn't write the websites. They simply indexed human knowledge and made the retrieval process completely frictionless and free. They built a search engine that made curiosity instantly actionable.
Right. And Fagat connects this brilliantly to mobility, because humans don't just have latent curiosity. We have latent mobility questions.
Yeah.
We have trapped questions about physical movement, like, how do I get across town to that specialized bakery if I don't own a car? Or how can my visually impaired teenager commute to their first job safely?
Or how can my elderly father get to his doctor's appointment when the buses don't run in his specific suburb?
Yes. Historically, traditional public transit only answered a tiny fraction of those mobility questions. It only answered the questions that aligned perfectly with a fixed route, a fixed schedule, and a physically capable rider.
If your mobility question didn't fit the bus schedule, your demand remained unmet.
You just stayed home.
Exactly. But the low-cost, omnipresent robotaxi network acts as a search engine for physical movement. You have a mobility question, you type it into the app, which is just your destination, and the network executes the physical retrieval effortlessly.
Mhm.
It removes the friction from physical space, just as Google removed the friction from information space.
So if we extrapolate that, if physical movement becomes completely frictionless and costs pennies on the dollar, how does that actually reshape the physical geography of our lives? I mean, there is a concept in urban planning, Marchetti's constant, right?
Oh, yes, the 30-minute rule.
Right, the idea that humans have historically always been willing to commute about 30 to 45 minutes to work, regardless of the technology. When we walked, cities were a few miles wide. When we got trains, suburbs expanded 20 miles out.
Yeah.
If the commute is suddenly dirt cheap, you don't even have to drive. You can just sleep or work or watch a movie in the Cybercab. Does the boundary of the suburb just explode? Can people start commuting 2 hours from rural farms into the city center?
It creates a massive geographical reorganization for sure. On one hand, yes, the reduced stress of the commute could incentivize sprawl. People might accept a 60-mile commute if they're just reading a book in a plush pod. But conversely, the removal of parking lots, which we will definitely discuss shortly, could massively densify the urban core, making city living infinitely more attractive and affordable.
And beyond the real estate, think of the reclaimed human capital. Millions of people currently spend an hour a day white-knuckling a steering wheel in stop-and-go traffic.
It's awful.
That is a state of high cognitive load and high stress that produces absolutely zero economic or personal value. Reclaiming that time, giving humans back an hour of their day to rest, to connect with family, or just to think, is a profound societal shift.
Not to mention the financial capital.
Yeah.
Transportation is usually the second highest household expense after housing. A new car, insurance, maintenance, gas, parking, it drains massive amounts of disposable income.
Oh, yeah.
If the cost of mobility drops by 80% because you just subscribe to a network, instead of owning a depreciating asset, trillions of dollars globally are freed up to flow into other sectors of the economy.
Okay, this all sounds incredibly utopian. A world with no crashes, cheap rides, reclaimed time, and perfectly routed AI traffic. But whenever a structural foundation of society shifts this radically, the friction is immense.
Oh, there will be massive growing pains.
The transition is never clean. We really have to address the ripple effects, the pushback, and the very real logistical nightmares that the sources highlight.
It is critical to ground this in reality. The transition from human-driven, manually routed transit to AI-optimized fleet networks will be one of the most highly contested civic battles of the decade. The resistance will come from both physical urban realities and entrenched political structures.
Let's start with the physical reality. The main criticism cited in the source material is the concept of induced demand. We touched on this briefly, but let's go deep.
Induced demand is huge.
Urban planners have warned for decades that if you widen a highway to reduce congestion, the congestion simply fills the new lanes. If transportation becomes incredibly cheap and easy, people will just use more of it.
Right.
If it costs me 50 cents to send an empty Cybercab to pick up a single pizza across town, I'm going to do it. And then you end up with roads clogged with zero occupancy ghost vehicles running trivial errands.
Induced demand is basically a fundamental law of traffic dynamics. Lowering the cost of a resource increases its consumption. If unmanaged, a flood of 20-cent per mile pods would paralyze the city grid. However, the counterargument to this relies on the systemic intelligence of the network.
What does that mean in practice?
Well, a decentralized system of human drivers cannot coordinate. We're all just guessing. But a centralized AI fleet operates like a hive mind. It has perfect visibility into global network demand.
Right. It's not just a bunch of individual cars guessing where the traffic is.
Exactly. The network uses algorithmic pricing and dynamic routing to prevent gridlock. If a dense downtown corridor is approaching its maximum flow capacity, the system automatically shifts incoming demand to those high-occupancy Robovans we talked about.
Oh, so it forces efficiency.
Right. It might introduce surge pricing for single-occupancy rides or dynamically batch package deliveries with human passengers to eliminate those ghost trips. Think of it like vasodilation in the human circulatory system. The AI dynamically expands and constricts flow based on real-time cellular demand.
That makes sense. But even if the AI perfectly solves the physics of traffic, it cannot solve human politics.
No, it certainly cannot.
The municipal and political hurdles here are staggering. I mean, we are talking about replacing the municipal public bus system. That means displacing tens of thousands of unionized bus drivers, transit workers, and municipal maintenance crews. You are taking a public utility, mass transit, and essentially outsourcing its core function to a private, for-profit corporation.
It's a massive shift.
I can see a city council fighting this tooth and nail. That's a massive political hurdle, right?
And historically, they do fight it.
Hmm.
The privatization of public infrastructure always involves intense friction regarding equity, data ownership, and labor displacement. The municipal transit authorities will demand guarantees. Who controls the transit data?
Right.
If a private company runs the mobility network, do they share passenger flow data with the city planners? How does the city ensure equitable access? If the algorithm determines that deploying cybercabs in affluent neighborhoods yields a 3% higher margin than deploying them in underserved communities, what prevents transit redlining?
These are the exact battles happening in city halls right now. You can't just drop an app on a city and expect them to happily hand over the keys to the infrastructure.
What the sources indicate, however, is that the sheer economic pressure usually forces a compromise. Municipalities are currently drowning under the financial weight of operating subsidized bus networks. They run massive, massive deficits. When a company arrives and offers a mobility solution that requires zero municipal capital expenditure, zero pension liabilities, and actually provides higher frequency service, the financial gravity is really hard to resist. The rollout will likely take the form of public-private partnerships, where the city maybe subsidizes rides for low-income citizens on the private autonomous network.
And Tesla's specific advantage in navigating this, according to the sources, comes down to their vertical integration. Because they aren't just selling a piece of software to a city, are they?
Right. Contrast Tesla with other players in the space. Some companies build autonomous software, but have to buy vehicles from traditional automakers.
Like Waymo buying Jaguars.
Exactly. Others build cars, but rely on third-party charging networks. But Tesla is vertically integrated from the silicon all the way to the street. They design the AI training chips in their own data centers. They write the FSD V14 Plus neural nets. They manufacture the Cybercabs and the batteries. They own the supercharger network that fuels the fleet. And they write the consumer-facing ride-hailing app.
So when a sensor fails or a charging protocol needs to be updated, they don't have to call a meeting with 3 different corporate partners to figure it out.
Nope. They just push an over-the-air update. That iteration speed allows them to drive the cost curve down way faster than a fragmented competitor.
It creates a closed-loop feedback system. Every mile driven by a customer generates data that trains the neural net, which makes the software safer, which lowers the insurance costs, which allows them to lower the fare price, which attracts more riders, which just generates more data.
It is a classic flywheel effect,
Yeah.
completely insulated from third-party bottlenecks.
So bringing all of these massive threads together for you, the listener, we started this deep dive looking at a single online exchange, Adam Lois and Elon Musk, pointing out that vision-based neural networks are poised to virtually eliminate the tragedy of human traffic fatalities. But thanks to Paramendra Bhagat's analysis, we've unspooled what that safety actually unlocks.
It unlocks the economic viability of the autonomous fleet.
Exactly. We've looked at the $30,000 manufacturing cost of the unboxed Cybercab. We've deconstructed the 20-cent per mile operating economics when you strip away the human driver and run the vehicles on wholesale electrons.
Yeah.
We've seen how the high-capacity Robovans and the nimble Cybercabs form this biological hybrid network that finally solves the last-mile problem. And we've explored the profound societal shifts, waking up millions of dormant vehicles like Airbnb did for rooms, and indexing physical movement to make it frictionless, just like Google did for information.
It's all connected.
The reality arriving on the streets in 2026 isn't just about cool robots. It is a structural shift that takes the historical luxury of a private chauffeured ride and drives the costs so relentlessly low that it becomes the new public bus.
It really is the ultimate democratization of physical movement. But as we process the scale of this transition, there is one final lingering implication that we haven't touched upon yet, and it might be the most visually dramatic change to our daily lives.
Ooh, lay it on us. What is it?
If we successfully execute this master plan, If a hybrid network of endlessly circulating, fully autonomous, hyper-efficient electric vehicles handles the vast majority of our urban transportation needs, and those vehicles are constantly in motion, serving ride after ride, what happens to the physical real estate of our cities?
Oh, wow.
Think about it. Right now, massive percentages of our urban footprint are dedicated solely to storing dormant metal boxes. We have multi-story concrete parking garages dominating prime city blocks. We have massive asphalt moats surrounding every shopping mall. We have street parking choking the width of every residential road.
So if I take a Cybercab downtown, it drops me off at the curb and then immediately drives away to pick someone else up. It doesn't need to park. It doesn't sleep.
Precisely. If the vehicles don't sleep, they don't need a bedroom. We are suddenly looking at a future where cities can reclaim perhaps 20, 30, or even 40% of their physical landmass. The next great challenge of the autonomous age won't be writing the software. It will be answering the physical question. How do we redesign the human world when we finally erase the parking lot?
That is wild to think about. Do those concrete garages become vertical farms?
Maybe. Do the asphalt moats become high-density affordable housing? Do the curbside parking lanes become massive, continuous greenways for pedestrians and cyclists?
That is an incredible thought experiment. It means the true legacy of the autonomous car might not actually be about the cars at all. It might be about giving the city back to the humans.
I think that's exactly right.
From the milliseconds of a neural network processing a stop sign, to the macroeconomics of a municipal transit budget, to the literal redesign of the earth we walk on, the real revolution is always deeper than the surface tech. Thank you for taking this deep dive with us today. Keep asking the big questions, keep looking beneath the headlines, and we will catch you on the next one.